Good evening, everyone. Welcome back to my channel. So, as you have seen, we have covered two videos on basic proportionality theorem. In the first video, we have discussed what is basic proportionality theorem. And in the second video, we have discussed how to prove the theorem basic proportionality theorem. So here comes the part 3 of basic proportionality theorem, where we are going to discuss some examples based on basic proportionality theorem. Okay, so let's start with few examples. Okay, so here is a triangle. See, in the given figure, in triangle ABC, what is given? DE is parallel to BC. So first of all, whenever we proceed a questions that is based on geometry, the first thing that we do is we write the given things and we write what we have to find or what we have to do. And then we proceed with the question. So I'll start with the same. First of all, I'll write what is given in the question. So the first thing that is given to me is DE is parallel to BC. Okay, yes. And next, AD. What is AD? It is 4x minus 3 centimeter. So I'll write here also 4x minus 3 so that I can clearly see the picture and solve my problem. Okay. Now AE, that is 8x minus 7. So AE is 8x minus 7 centimeter. Next, BD. BD is 3x minus 1 centimeter. So BD is 3x minus 1 centimeter. And the next value with us is CE, that is 5x minus 3 centimeter. So this is 5x minus 3 centimeter. What is the value that we need to find is? We need to find the value of x. So I'll write what I need to find value of x. Okay, so as we can see that DE is parallel to BC, then according to BPT, according to basic proportionality theorem, AD upon DB is equal to AE upon EC. So basically when DE is parallel to BC, it divides the other two sides in equal ratio, which gives us, according to basic proportionality theorem, which is also known as Thales theorem, AD upon DB is equal to AE upon EC. Correct? So D and E divides the sides in equal ratio. Now what I'll do, I'll substitute the value of AD and DB. Okay, just a minute. Okay. So here I got AD 4x minus 3 upon DB is 3x minus 1 is equal to AE 8x minus 7 and CE, that is 5x minus 3. Now how I'll proceed? I'll do cross multiplication. Okay. So now cross multiplying 4x minus 3 multiplied by 5x minus 3 is equal to 8x minus 7 multiplied by 3x minus 1. Okay, so I guess everyone knows how to multiply two binomials, right? So on multiplying this, I got, just a second. Yes, 20x square minus 15x minus 12x, that is 27x plus 9 is equal to 24x square minus 21x minus 8x, that is 29x plus 7. Okay, now I'll shift all the terms to the left hand side or right hand side. So I'll get 4x square minus 2x minus 2 equal to 0. Okay, if I am not wrong, 4x square minus 2x minus 2 equal to 0. Yes, so I can take 2 as common. 2x square minus x minus 1 equal to 0. Now I'll do the middle term splitting. So on doing middle term splitting, I'll get 2x square minus 2x plus x minus 1 equal to 0, which implies 2x common x minus 1 plus 1 x minus 1 equal to 0. Now, x minus 1, 2x plus 1. Okay. So solving this, I got x is equal to 1 comma minus 1 by 2. So these are the two values of x that on substituting in the length of AD, DB, AE and EC, we will get the equal ratios. Okay. So likewise, we solved the first question. We'll move to the second question that is a little different. That is completely based on proving. Okay, so let's see how this question can be solved. This is one of an important question, and if you understand this question properly, you will be able to grab the concept very easily. Okay, so see, first of all, what it is given is DE is parallel to AC. So I'll mark DE. Here it is D, right? DE is parallel to AC and DF is parallel to A. So first of all, what is given to me is DE parallel to AC and DF parallel to A. Okay. And what I need to prove is BF upon FE is equal to BE upon EC. Okay. So this is given to me and this I have to prove. So now I'll begin the solution. First of all, take the triangle in which the two parallel sides are there. See, for example, if I take this triangle A, B, E. Can you see this? Triangle ABE? Yes. So in this triangle ABE, I have DF that is parallel to triangle ABE. Right? So I'll take in triangle ABE, DF is parallel to AE. Thus, according to BPT, I can say that BD upon DA is equal to BF upon FE. Correct. BD upon DA is equal to BF upon FE. Now, I'll move to the triangle where the other two parallel sides are. See, you can see the triangle here. See, in triangle ABC, you can see there is the parallel side also, AC and DE. DE is the parallel side, right? So now I'll consider the triangle in triangle A. Oh, wait a minute. In triangle ABC, DE is parallel to AC. So again, according to BPT, I can write see what I can write. BD upon DA is equal to BE upon EC. Right? I'll mark this as equation 1 and this as equation 2. Can you just compare equation 1 and 2? Both the equation have a ratio BD upon DA. Right? Both the equation have the ratio BD upon DA. So we can say that from equation 1 and 2, we get, what do we get? BF upon FE is equal to BE upon EC. Yes, and this was the only statement that we have to prove. Yes, so is it easy? Had we proven it very easily? Yes. So basically, if you are clear with the concept of basic proportionality theorem, in basic proportionality theorem, only you have to take care that there is a triangle. In the triangle, there is a line that is parallel to one of the side of the triangle, and that line is dividing other two sides in the equal ratio, right? And using that concept, I have proven BF upon FE is equal to BE upon EC. So I hope you are clear with the concept of basic proportionality theorem now, and you will be able to solve the questions, right? Okay, so thank you very much.
Please subscribe and press the bell icon.